The IOStream library is fairly rich, but most of it is there as back-end support, and there's really just a few classes that you'll normally use. Let's open up iostreamformatting.cpp, and we'll paste this into our working project and open it up, and let's compile it and run it. And we start here, and you see that I am including two headers, IOStream and IOManip. That's for manipulating the IOStream, and we'll be doing quite a bit of that. And the first thing we do is we put out a prompt and wait for something using cin. So cout is for printing out to the standard out, and cin is for reading from the standard in. And so if I type a few words here, 1, 2, 3, 4, 5, and I press enter, and you get a whole bunch of stuff there. But you'll notice that the input is 1, and that's because the cin class, it takes just one word at a time. And so it put one word in our istr string that we initialized there on line 10. And then on line 13, we sent it to the standard output with cout, and you see there it is, just the one word. You've seen we have displayed numbers, we've displayed strings, we've displayed all kinds of different stuff with cout. And cout seems very flexible in that it can print out a lot of different types. And in fact, by overloading the left shift operator, it's even possible for you to make your own classes work with cout. But cout also has the capability of formatting in different ways. And this is supported by the IOManip header here. And so let's take a look at these. We have three integers, I1, I2, and I3, and they're 42, 127, and 5555 respectively. And so if we look at all of them in the default format here, just scroll down to that, you see they print out as 42, 127, and 5555. So we can print it out in hex by first calling the hex manipulator, and then all of the integers after that are printed in hex, 2a, 7f, 15b3. We can call it with showbase, and so showbase is another manipulator there, and it'll show them with the 0x before them so that we can see that they're hex. We can call them with octal with showbase. You see, because we had showbase before, it's staying on for the octals. And then we can call no showbase and decimal to reset it to decimal in the way that we normally expect it. Now we can do interesting things with floating point numbers. You'll notice in our default format, it shows a certain number of digits. And here we're initializing our three floats to pi, 1234.5, and 42 to the 10 minus 10th. And you see the way these are printed normally. These are with a fixed number of digits. We can set them all to print in scientific notation by using the scientific manipulator. We can set them to fixed with 3 decimal places, set precision 3, or scientific with set precision 7. There's scientific with set precision 7. And back to default by using this unset flags and calling it with IOBase float field. It's a little bit complicated of a syntax, so you're not going to remember that. You'll need a reference to use these features. We also have string formatting options. So we have 3 different strings of different lengths, and 49, 50, and 51 prints them out just like this. We can set the width and right flush them, setting the width to 64 and calling right, and they will look like that. And with the set width and the right, we can fill it with dashes or we can fill it with spaces. And we can set it back to flush left with the left manipulator. So those are some of the formatting options that you have available with cout. Some of these might be useful for printing reports and things like that. And you might want to actually send these to a file instead of sending them to the console. And for this, we're going to look at iostreamfile.cpp. So first let's delete this one. And we will run clean so that we can run another project, and we'll copy and paste iostreamfile.cpp. And we'll compile it and run it. So we can open files for write, we can open files for read, we can open files for append. Let's take a look at how this is done. So first of all, you'll notice that I'm including string and fstream in addition to our normal IO stream. I have a little function here at the top for formatting line numbers, and we'll be using that later on. It returns a string with a line number in it. And we define a file name and a buffer for reading up there in line 16 and 17. And then starting in line 19, we're going to write a file. And so you'll notice we declare OFStream. That's an out file stream. It's called OFile, and we're passing the file name to the constructor. And then we use OFile just like we would have used cout with the left shift operator. And we send it a line number and a space, and then this is the test file. So that calls our line number function, which simply gives us a sprintf formatted 2-digit number. And we can see those here. So we write the file, and we're just writing 3 lines of the file with this is the test file, and then we close the file on line 25. And then we open the file for read using an ifstream and an infile with the file name. And in a loop, testing while infile is still good, we call getLine, and getLine takes the ifstream as its first argument, and the buffer is its second argument, and line by line, it puts a line in the buffer. And we cout the buffer with endelse. So getLine is not giving us those new lines, and then we close it. And so this is us reading the file that we just wrote. There's those 3 lines, and the line numbers 1, 2, 3. Now we're going to append to the file. We're going to open the file for append. And so we're using fstream, and we're calling it a file for append file. And our constructor has the file name, and then it has some flags which are ORed together with the bitwise OR operator. And the flags are from the fstream object. They're in, out, and app. And app stands for append. So this is being opened for input and for output and for appending. And what that means is when we open the file, we can read from it, we can write from it, but it's positioned for appending. We're positioning the write pointer at the end of the file. And we test to see if we opened it successfully, and if not, we'll print out failed to open. And first we print out the current contents of the file. And so down here we open the file for append and we print out the current contents. So in order to print out the current contents, we first have to seek to the beginning, and that's done like this, using the seekg method on the append file. And then we check, we do it just like we did with the in file. While it's good, we use getLine and cout. Now we're at the end of the file, and so we have an end of file flag, and we can't use the file again until we clear that flag. And so on line 49, we have to clear the flags with afile.clear. And now we append to it, and we do this simply by writing to it in the same way that we wrote to the first one. So remember, we wrote to the first one, OFile with the left shift operators. We do the same thing here, starting on line 52 through 54. Now we should have 6 lines in the file. And so we seek back to the beginning and we read the file and print it out. And here we have it with 6 lines in it. And then we close the file and we call remove to delete the file. So you see the file is not showing up here. Press F5. See, it's not showing up there in our file system. So that's how you read and write to a file using the IOStream functions. So the IOStream library is very useful for basic and generalized I/O, including interfacing with the console and writing to and reading from files. For more control, I suggest you use the C standard library functions for reading and writing files. Let's delete the working file and run clean to get set up for the next lesson.